And welcome back to another LeetCode video. Today we're looking at LeetCode 3397, maximum number of distinct elements after operations. So in this problem we are given an array nums and an integer k, and the question is how many distinct numbers in nums can we create when we are allowed to perform the following operations on each element of the array at most once. The operation is that we can add an integer in the range of -k to +k to the element. So you can see here we're given a range or a list of numbers, and here in this example they're actually sorted, but in the problem it doesn't guarantee that they're sorted. And you can see that some of them are duplicates, like the 2s and the 3s. However, we can map them to other numbers by adding or subtracting the values between plus k and -k to make as many of them distinct as we can. And in this example, we can make all of them distinct, and then the result is the number of elements in the array. Here in the second example, we can see 4 times the number 4, and our k is only 1, so we can only add or subtract 1 from 4. So that would give us, I guess, 3, 5, and we still have 2 4s left that are duplicates. So the result is then 3. Right, and you can see that k can even be 0, and nums is guaranteed to have at least one element, and all of the numbers are positive. However, to modify the array, they don't need to stay positive, as we can see in this example here. All right, so how do we approach this? Well, if the numbers are sorted, I think we have a chance of dealing with this. So let me just copy this description, and let's swap to the drawing board. Right. So if we have a couple of numbers, and this is the idea how to solve this. If we have a couple of numbers and some of them might be duplicate. Let's say we have maybe a 1, a 2, another 2, and so on. And let's say our k is 1. Our k is 1, 3, 5. So you can see that we can make all of them distinct by subtracting 1 from 2 and by subtracting 1 from the 1, right? That would give us 0, 1, 2, etc. So all would make all of them distinct. Now, this trick only works when these numbers are in sorted order, because what we can do is we can compute a larger range of numbers that go from whatever the first number is, and maybe we could call this A, and maybe the last number we call that B. But the range to which we can map our original nums array is essentially A minus k to b plus k, right? So the way to solve this problem is to be greedy, and we're going to try to map the first number instantly to a minus k, and that is guaranteed to work because there are no numbers before that, right? And we're not going to return how many operations we performed on the array. We're just going to return how many elements are unique after performing this operation. So we can just perform this operation without any impact, really. So that is exactly what we do. We map the first number here, and in this case this would be -1, well, 1 minus 1, so this would become 0, right? And the second case we do the same thing. We're greedy, but now the next number that can be used to mapping is, well, it's this value. So if this would be, maybe running out of letters, let's say this is C. Well, we can map it to C minus K, right? And that's exactly what we're going to do. We're going to map it to 2 minus 1, which is going to be 1. Now the next value that we can do is, if this was D, is D minus K. So we're kind of updating our minimum value that we can map to. But now if we map to d minus k, what do we see? Well, d minus k is 2 minus 1, which is also 1. So the 1 is already taken. So what we need to do is we need to update our minimum value. So we actually need to map it to d minus k plus 1. Plus k plus 1. And the reason is that we've already used that value here. So what we need to do is we need to keep track as we iterate through our array, what is the minimum value we can map to? And whenever we use a minimum value, we have to increase it by 1 so that we don't use that minimum value twice as we would in this example where we have these 2's, right? Yeah, and that's the whole idea. And we continue to do that. And maybe at some point, if there are different numbers in the array here, we run into the case where we try to map to b plus k and plus 1, and that doesn't exist, so we cannot map it. So we won't perform the mapping, and we're going to decrease the amount of unique numbers that we have, right? So the above is kind of like a, so this, maybe an analogy for this is the slow and fast pointer problem. This is fast. Fast. I would write with my mouth. Fast. Where the minimum value here gets updated at least as fast as the value in the nums array minus k. But when we use a value and we then want to reuse it, we have to update our minimum value once again. So the minimum value is moving as fast or faster than the slow value. And so let me show you how to do that. Well, first we have to sort the numbers because they're not guaranteed to be in sorting order, but for approach we need that, right? Now what we will do is we'll keep track of the count of unique numbers. I'll just use a result variable for that. You can use whatever you like. Some people call it res or count or whatever. And we have to keep track of, well, what is our current minimum value that we can use? And the current minimum value is going to be, well, initially for the first element, it's going to be nums at position 0 minus k. And what's the maximum value we can use? Well, it's the same, but plus k, right? So we can assign num0 to any value in between current min and current max. Right. Now we need to iterate over all of the numbers. So for n in nums, what do we do? Well, we have to update our minimum value. That's the first thing we have to do. So the current minimum value is going to be the maximum between the minimum value that we already have and the value n minus k. So that ensures that we keep track of what is the lower bound of what we can map n to. Now, for the max value, that's a little easier because that's just n plus k always. Since the array is in sorting order, current max is also in non-decreasing order. So we can just do it like this. We don't need a maximum here or something. Right. So now we have to perform a check. Can we actually map this number to a value in that range? And that is only true if the minimum is smaller than the maximum. So if the min val is larger than the max, then we can't do anything. So we're just going to continue. But if that's not the case, well, then we know that we can map n to a unique value and we can increase our result counter. We just need to also keep track of the fact that we've just used that min val. We have to increase it by 1. So the next time, the next iteration of the loop, when n stays the same because maybe we have 2 2's in the array, our current min value is still, the n minus k isn't changed, but the min value has been increased, right? So if you have an array with lots of same numbers, what will happen is the min value will creep up until it's larger than the max value. And in that case, you know, we know that we cannot map that number to a unique value anymore. Right, so, well, Surprise, surprise. That's the whole thing. So let's run the tests. Wrong answer. Okay, what do we have here? Output was 4. Let me see. Okay. You have minus k, that is correct. Here we have minus k. Here we have plus k. If the current min value is larger than current max value, then you continue. Oh, I deleted the increment for the min val. Okay. Right. So there you go. And when we submit this, it should pass all of the tests. Very nice. So it does that. So now quick runtime and space complexity analysis. Well, obviously we're just iterating through the array 1, so that's O of n. But we're doing the sorting, which is n log n, right? So n log n dominates the time. And how much space? Well, we'll have constant space, which is very nice. Whoops. Which is very nice because we don't really need to store anything. We just keep track of the min and the max for the range for the mapping. Yeah, and that's the whole thing. So yeah, thanks for watching.